smaller it is, the harder the vocab gets. Like right now, we're doing like the blood cells and stuff,
I
and
need
it's
you to
like
push that away.
neutrophils.
Alright.
Like the small stuff is
Okay, so let's go over these problems. First things first. Oh, you can't see anything because I still have the slides up. I will say, does anyone have their homework ready to turn in? Some, but not complete.
I needed an extra question on.
So like on the right or that review problem?
Yeah, the review.
Okay, let's look at that quickly in a second. The literacy for all, by the way, some people were freaking out. Yes, it is due today, but as long as you get it to me this week, timing isn't a huge issue for the literacy for all. The one thing to be aware of is the reason why I had it due today is because you'll have more homework this week. So, what do you mean, wow? Like,
I was gonna get out for Thanksgiving.
yeah, so you're gonna have a week-long break. I assume you don't want me to give you homework over Thanksgiving break. Okay, so leave the literacy for all on the empty desk. So that's what I was saying, it should be due today. But as long as you get to me this week, it doesn't impact your learning of the content we're on, so I'm not stressing on time. But I am stressing, like, I'm grading over Thanksgiving break, so I need it before Thanksgiving break. So let's talk through these problems quickly. So finding the roots of the following equations, right? Just write each equivalent equation. Don't show inverse / zero product property. So what we had was the equation x squared, or we were looking for roots, right? So f of x equals x squared minus 6x plus 12. One of the big issues I'm seeing right away is I do see someone with a root. I see someone with maybe a factored form in there. When I look at this problem, right? If I'm looking for a root, what's the first thing I need? I will need to graph it, but what? I need a 0 equal, right? If it's a root, I know f of x is 0. That's a thing to keep in mind. Okay, I'm going through this quickly because there's a lot of content we've already covered. This is more to help us prepare for a retest if we want. Everyone should have their test back by this point. So I do need to graph it because what do I need to look for? Well, I do need to look for the zeros, but I don't know what the zeros are based on. Yeah, if you look at this, yeah, there's x squared minus 6x plus 12. Do you see any roots even there? Nope. So what can I use if I don't know what the roots are? Vertex form. Remember, I can't solve it in standard form, but I can rewrite it in vertex form. I do have a vertex. I don't have x-intercepts. Right? There's my vertex. I believe that's what, 3, 3? So 0 equals a times x minus h squared plus k. What is my a value? 1. Remember, it's understood to be 1 here. Jeremiah, I would take some notes on this since you have to do the retest.
So which one do you have to find the a value and write it out?
So like if I give you an equation to start, you always know the a value because remember, a is right here. But if I give you a vertex and another point, have I given you a?
No.
So you would have to figure out what a is in that case. Okay. Right. And so that's why I assigned that review homework that is due tomorrow, because we need to practice with that skill. So what is this h value here? 3 squared plus 3. Now I can solve this equation. So negative 3 is equal to x minus 3 squared. So what am I going to do next? Take a square root. So just the square root of negative 3 is equal to x minus 3? Alright, anytime I take that square root, I got to do plus or minus. But also remember, I'm taking the square root of a negative, so what kind of number am I going to get? Remember, that's the same thing as negative 1 times 3? So I'm going to get what number? I. So plus or minus square root of 3i is equal to x minus 3. So 3 plus or minus square root of 3i is equal to x was the answer. So remember we had it squared. The inverse of a square is square root. That's all it is. Okay? So I will point out, was there another method we could have used here to solve that quadratic equation? Quadratic formula, right? I had a nice vertex, so I used vertex form, but you can always use the quadratic formula. You can always use the quadratic formula. So what is the range? Okay. So what do we mean by range? The y-intercept? The y-axis? Not quite the y-axis. It is a y, but not a y-axis, because I would want you to remember, this is the y-axis, right here. That's the y-axis.
How far is this?
So it's the y what? Values. It's our outputs, right? It's y values are outputs. Every time I do range, it's y values are outputs. And so I saw some zeros, which I'm assuming that comes from here, right? Is that the lowest y value though? What's my lowest y value? There's no y values below that point? Notice this graph is going to keep going down, right? So what is the lowest y value? Okay, so remember, this is not a minimum, it is what we call a relative minimum. Meaning it's the lowest for that little section, but it doesn't necessarily mean it's the lowest overall. We're going to talk about the difference between a relative minimum and an absolute minimum today. Okay, which is why I included these questions as well. Relative minimum, but the lowest y value is negative infinity. What's the maximum y value then? Right, it's going to keep going up. We're good on that idea, right? So the lowest y that there is in general to the highest y. So what do we mean by domain? Those x values. Alright, so x values or inputs. And so what is the lowest x value? Yeah, it's going down, but it's going to keep going to the left, isn't it? So negative infinity. All the way up to. And a quick thing to notice about this is, because we call the domain, or the domain is the x values, which is the inputs, is there anything I cannot plug in for x? Can anyone name a number I can't plug in? No? So negative infinity to infinity. Every number that exists I can substitute in for x. That's an easy way to recognize that the domain is negative infinity to infinity. Okay. I know I'm moving quicker, but we got math, new math to cover. So the roots, the product is first. Not many of us got here. But what do I mean by, oh wait a second, slow down just a hair so y'all can finish writing. What do I mean by product? Huh? What? Multiplication. Product just means multiplication. Okay? So, we talked about a couple of different methods. What is one way that we can multiply those binomials? Distribute, right? That's the simplest way in my opinion. I like that one, but what was the other method? the box, the area, right? It's called an area model, and so you can do that as well. X minus 3, x plus 1, right? X squared minus 3x plus 1x minus 3. And so x squared minus 2x minus 3. Just don't forget, I still have to multiply that by the second x plus 1. When you look at the equation originally, it's only x minus 3 times x plus 1 squared. So where in the world, it's already multiplied by x plus 1, so why do I have another? It's squared, meaning I'm repeatedly multiplying. And so if you're doing the area model, which I've already done it once, doing the x plus 1 squared first, so that's why I'm using the area model this time. But x squared minus 2x minus 3, so x cubed plus x squared, negative 2x squared minus 2x minus 3x minus 3. So I get x cubed minus x squared minus 5x minus 3. Notice I did the x plus 1 squared over here using distribution, but did I get different answers? No. So does it matter which method you use? No. Does it matter what you multiply first? No. You can do it in any order you want. Alright. Okay. One word of caution here. So a lot of us are recognizing, the ones who did this, that we have the roots 3 and negative 1. Remember, if you do not write the roots as points. When do you write it as a point? When it's x intercepts, right? So if I ask for x intercepts, you write it as a point. But if I ask for roots or zeros, you write it as x equals, right? And so I will remind you, you don't have to solve it all the way out, or solve it all the way out. You don't have to set it equal to 0, stuff like that, because how can we recognize the roots immediately in factored form? Well, remember it's x minus what? R1, right? Isn't x minus R1, R1 being the root? So that means x is equal to 3, right? So here x is equal to negative 1. Now remember, that's also coming from setting each of those factors equal to 0. Because it's 0 is equal to x plus 1, so what would you need to do to solve that equation? Right, subtract 1 from both sides. That's why it comes out to be x equals negative 1. Similarly here, I would need to add 3 to both sides. So x equals positive 3. Right, so identifying that x minus R1 will give you the same answer as setting it equal to 0 for those roots. Any questions through this point? No? So a lot of us who got here noticed that this was a multiplicity of 2. How did we know? It's squared. Also, look at the graph. Actually, that's hard to see. How do we know it's... Look, ooh, can't see jack up there. How should we know that it's a multiplicity of 2? Looking at the graph, what's it doing? See how it's touching and then going immediately away? That's when it was an even multiplicity, right? If it was an odd multiplicity, it goes straight through. That was something we talked about on that last day before y'all had to get out here and go to something early. I think it was the Veterans Day thing. Okay, last thing, relative maximum and minimum. Hopefully we're able to identify those things. Just looking up here in general, where do we see a relative max and min? That would be a relative max, and down here is a relative min, right? The highest for that section, lowest for that section. The big thing to keep in mind here is how do we write it? Okay, the one maximum is really easy to see. To get the minimum, I would have to, nope, skip that. I would have to do analyze and minimum, right? So the big thing to keep in mind is how we write it. When we say it's a minimum, that means it's the lowest. Is that an X or a Y idea? So that is a relative minimum of the Y, negative 9.48, at X equals 1.67. That's how we write our max and our min, right? It's a minimum of the Y value, right? It's the lowest Y value at whatever the X value is, every single time. Okay, we'll get more practice with that throughout today. Alright, so here's our agenda. So we're going to finish up topic 3, lesson 1. So odd I can't even, but that's focusing on end behavior. Then we're going to quickly just look at the definition of what a polynomial function is before getting to lesson 3, polywog, key characteristic of polynomials. This will wrap up every major idea within analyzing polynomials. We'll get one more lesson after this that allows us to practice everything, and then only one new concept, okay? So we will have an understanding check / test on everything Wednesday or Thursday. Wednesday we are going to start new content so that we're not too far behind after Thanksgiving break, because I plan to have 2 more units, but we're only going to have time for 1 more. So we got to get through some more content before y'all leave my class. So remember, we're just focusing on end behavior here. I should have made a note of what page this is, but I didn't. Sorry. Does anyone remember from the book? This is so odd I can't even. Past that. Past that. Here we go. It's on page M1-195 to M1-196 is where we should be looking. (196) is where this page is where we should be looking right now. And we should have some of this filled out already. So we looked at this idea of a power function. Remember, that just means a variable raised to some power or some exponent. And so we started looking here, and we started to notice that there was a pattern in how the function behaves towards the ends. It kind of looks different in the middle, but we saw what was happening there. We drew out those points, and I think where we left off before you went down to Veterans Day celebration was we talked about why it flattens as the degree increases between -1 and 1, right? And remember, it's the whole idea that if I take 1/2 and I square that, I get 1/4. If I take 1/2 though and I cube it, I get 1/8. 1/2 to the 4th, I get 1/16. What is that getting closer and closer to every time? It's getting closer and closer to 0, was the idea. So in the middle there, that's why you can see it on this previous page, right? The closer, the higher power we get, the more it flattens out in the center, right? But what we need to focus on, right, so I'll go ahead and tell you, that's not going to be on understanding checks. What we'll be looking at is the number 2 here, observing the behavior of each function on either side of 0 using the tables and graphs. So what we mean here, when we say the behavior of each function on either side of 0, what I am specifically referring to is the end behavior. Bless you. Right? And actually, I think we started to take notes about end behavior, didn't we? So we did do this already? Yeah. Okay, so we're further along than I thought. Cool. So remind me of this then. So if I have y = x squared, that does look like this function. And so when I say end behavior, I'm talking about where? The arrows, but to the far right and far left, right? So I'm literally talking about the ends. And so if I'm talking about the ends, what is x approaching? Okay, to the right it would be infinity. And so we would call that the right hand in behavior. And then we would also have as x approaches what? The left, which would be negative infinity, right? So the left hand. And if you get comfortable with it, you can abbreviate it that way. Left hand in behavior. So as x approaches infinity, what was my y approaching? It's still going up, isn't it, right? As we go to the right, I'm also going up. My y is approaching infinity. What about here? As x goes to negative infinity, so to the left, my y is going towards... Notice here it's still going up, so it's going towards positive infinity. We get on that idea? Any questions? Right, it's just looking at that graph and making sense out of it from there. Whereas if we looked at something like y equals x to the fifth, still as x goes towards, I still want the left hand in behavior. As x goes towards negative infinity, what's my y going towards? Notice for x to the fifth, right, it's going down, so negative infinity. But as x goes to the right, towards positive infinity, what's my y going towards? Heard DJ say infinity. Do we all agree on that idea? Yes? And so that's the major concepts we want to notice there. So a quick little note, all right, right here is the only time that those really change from that, and you just want to graph it, right? So straight up, I'll tell you this: to do in behavior, just graph the function, and then look at the graph. I'm not going to make it more complicated than that. Look at the in behavior, or graph it by looking at the graph. Okay. Do the in behavior by looking at the graph. I'm struggling with words today. All right. So when you graph these, you would get negative x, which means it has a negative slope. All right. When you have x squared, but you put a negative in front, you get negative x squared. So it'd be a concave down parabola. And then we would get negative x cubed here. Right there. Within your small groups, I want you to write the in behavior for those three functions really quickly, and then we'll come back and move on to the next part of today's lesson. Hopefully it won't take us too long. So work on getting that in behavior within your small groups, and we'll get going from there. What? So like, here's the line, right? So when we put a negative in front, we get negative x, so it's a negative slope. If we get negative x squared, instead of being concave up, it's going to be concave down. So write your in behavior off of those graphs. So I've already drawn the graphs up there too.
That's what I was adding.
I went ahead and drew the graphs. Yeah.
Yeah, he just did that.
No. I drew the graphs. What I'm asking you to do is the in behavior on these three. Yeah. So guys, I want you to do the in behavior for A. I already drew the graphs on there. I want us to focus on in behavior with these problems. Yes, ma'am.
Okay.
So we're supposed to start with negative.
So remember, and they have a work example here. It says in behavior. But what I want to know are two things. I want to know the left hand in behavior, right? So as x goes towards what? If I look to the left, what is my x going to go towards? To the left. So like think about these numbers, right? So that'd be like -1, -2, -3. So what is x going towards? Right. So as x goes towards negative infinity, what's my y going towards? So to the left, it's going up. So the y goes towards positive infinity. Okay, then I want my right-handed behavior.
Okay, so if it's the opposite of this, would just be.
So positive infinity for the x, right, it's just going to the right. What's my y going towards? So it's going towards right. Nope, you need this. You're stressing about a graph when you, oh, the infinities?
How do you write it without having to turn it into?
Practice.
Practice.
So one thing to be aware of is we want as x, you want an arrow. So that's saying x approaches negative
Okay,
infinity.
so what, how do you?
Come on, Grace. Do your behavior.
They all go to infinity.
The arrow to indicate it's approaching.
Okay, so. we put-
And what's the y approaching you? So you want that arrow again.
What I do is negative x.
No. I'm asking, I already gave you these graphs. What I'm asking you to do is do the in behavior for part A. Okay? So I'm just asking you to do the in behavior.
How, can I say we got their all negative? Oh, I didn't.
It should be wrong negative because they're up on the building.
How are we supposed to do this one? Are we supposed to do this?
So I want you to think about it. Use a right hand. As you're going to the right, x is going towards negative.
Okay, so what we're doing is.
Is this? All in line, what is it?
So like towards the right is going this way.
Like which one
Right?
is A?
So what's my x going towards when it goes to the right? Positive infinity. And then left-handed behavior is going to the left.
And Y is going to the side.
So on this side, since x is continuing that way, that's positive infinity. But since it's going down that way, it's y is negative.
So for this one, X would be negative.
So it's x.
And we're just rewriting that.
Most of the time it's opposite.
Say it one more time. Most of the time it's what?
Like opposite, like 100%.
Well, you have to get the right,
Unless it goes
Okay, so on this side.
So I was gonna say,
X
it
is
depends on honestly whether it's even or whether it's odd. I'm gonna talk about that.
negative.
Because notice, if it's x
on the
squared,
right,
On the right bottom.
They're both negative.
so when it's x squared, you see how they're going together?
But
Or the even powers? But when it's odd, it's going opposite
So like
directions.
this part right here
Does that make sense?
is positive and then the
So-
Y in there.
that thing right there, for the X, it's gonna keep going that way.
Do you have any questions so far? What's
Oh.
your question?
It's gonna keep going like
It's
down.
because you've been reading.
I thought that was the Y.
You didn't have another book out?
Like I bought X, you have to write
No,
that
yeah,
as just into
yeah,
like two
no,
different
yeah,
parts, so I
okay.
mean, X would be this part and Y would be that
Yeah,
part. So X would be positive because the X axis, this
Negative
side's
x,
positive.
negative x squared,
But
negative x
then,
cubed. You
so
said
Y would be
about
negative.
front here? That's why it's
Oh, we
not,
gotta do negative.
right.
Do I just like totally not get it, cause I don't think.
That's why this is
At all.
a negative slope, this should be concave down, and this should be
Okay, so
going
for
down.
this one, what,
Okay.
or you're
So-
supposed to.
That one I got, right hand goes negative, and left hand.
Okay.
So,
So you
but
do
to
each
start answering
side.
your
So
question,
how do
Council,
you
you're gonna
do-
start going over this in a second.
You just do
What we
it.
want are two things. We want the left hand in behavior. I just do EB for in behavior. And so if I want the left hand in behavior, if you look at these graphs, as I go to the left, what is my x approaching? So as x approaches, what? Negative infinity. Notice it's got an arrow. Is it ever gonna stop going to the left? No. For now. For what I will be ever test you on, yes. I don't wanna say it's always that. Oh, and then I wanna figure out where the line is approaching.
Unless it has a stopping.
Right, unless it has a stopping point, which it can in certain functions. So then the right hand behavior, right, as x goes towards, if I go to the right, what does x go towards?
Is she better?
Right. And so I just need to figure out what is my y approaching based on those two things.
We just
Okay.
got like
So talk about these groups, and I'll come back, we'll talk about this again. Yeah. I'm about to put it up.
Yeah.
That's right. I like
So this goes to.
Okay, so let's start going over this. Grayson, here where it's the negative x, as x goes towards negative infinity, what's the y going towards?
positive.
Okay? Anybody want to push back on that, or do we agree?
Wait, is that left or left?
So as x goes towards negative infinity, so which direction in the x is negative infinity? To the left or to the right? To the left, right? So we want to notice that's left-hand in behavior. As x goes towards negative infinity, the y is going up to positive infinity. Okay? Gracie, as x goes towards infinity, what's my y going towards?
Negative 13.
So negative infinity? Anybody want to push back on that? Do we agree?
She said what?
And she said, as x goes towards positive infinity, y is going down towards negative infinity.
But can it still go up? Well, oh, yeah, that's right, because I see it there.
You just have to look at the graph. You don't have to memorize it. You just have to look at the graph and know how to write it. And I do want to point this out. What do I always put here? Arrows. Why am I putting those arrows? There's a word I keep saying. As x starts with an A. Approaches. What I am saying with this arrow is it's approaching infinity. Can you ever reach infinity? No. So what I am literally saying is as x approaches negative infinity, y approaches infinity. We good on that idea? Any questions? Alright, CD. As x goes towards this negative infinity here, what's y going towards? Negative infinity. Anybody want to push back, or do we all agree? We're good? Okay. KJ, as x goes towards infinity, what's y going towards? Negative infinity? Okay. So this positive right here. So remember, we want the left hand in behavior. So as my x goes to the left, which is negative infinity, I also want the right hand in behavior.